Yeah, good afternoon. Yeah, my name is Niek. I'm from the Netherlands, so I hope you can all understand me. Today I go to talk about mostly InnerSource, but by doing InnerSource, we ending up building a complete developer ecosystem. So it will be the journey that we took over the last, I think, couple of 4 or 5 years, where we start and where we are today. A bit of lessons learned, and maybe some directions if you go that direction as well yourself. Of course, you can make as many pictures as you like, but I hope you spend your time on listening to the story. This QR code will lead you also to the slides that are on this GitHub repository's GitHub page, all done by CI/CD, of course. So you will find here the slides, so you don't have to make any photo from the slides, but of course, it's your choice. As I mentioned, I'm from the Netherlands. I'm actually from Eindhoven, and Eindhoven is the town where my company was founded about 130 years ago. So I work for Philips. It's not something a startup anymore. It's a big, large enterprise founded all the ways back in the days in the Netherlands. And when you think about Philips, maybe you think about the light bulb. This is then the very modern version. Maybe you think about other products Philips made. I see there a monitor. It's also Philips. Maybe you think about air fryers or about televisions. But what do you think about this? Anyone directly thinks about this if you think about the big company Philips? Anyone? No. So today, Philips is actually only doing things in health technology. So Philips today is mission is to improve the life of 2.5 billion people on Earth. So Philips is not making any more coffee makers, lights, televisions. They have still the brand, but the company is only doing things in the health tech space. So that is what my company is doing today. And to a little bit set the scene, we are smaller than in the past, but still big. And there are about 8,000 plus developers or people in software roles in my company. So that those developers are not only in the Netherlands, they are everywhere on the globe. They are in China, they are in India, Israel, Brazil, United States, Germany, and some other countries. So we have to deal with a lot of different cultures, working across the globe, almost, let's say, at least 6 days a week, because maybe you know in Israel they don't work on, I think, Friday, but they work on Sunday. So yes, we have at least 6 days to cover. And I mentioned we are medical, and medical is regulated business. So you have to comply to all kinds of rules to be able to bring your product to the market. Medical is not the only domain that is regulated, it's more, but it is important when you do software in your company that you're aware of those kind of things. And we are not just started with software. We already do that over 30 years. We have very large legacy bases, and we also have brand new apps. We build things for devices in C languages that are maybe even before the C standard. We are building cool new stuff for devices, maybe in Rust. We build things for the cloud, for web applications. We do a bit of everything. So that's a bit about what we're all doing and with who we're doing that. And we have some problems defined in the past. So there were a couple of things very, very hard in our company. And first of all, collaboration was very, very hard. The company exists on businesses across the globe. There are some acquisitions. They all work slightly differently. They work on at least 20 different version control systems. So it could be we have TFS 20 times. We have a couple of GitLabs and so on. Bitbucket, name it, everything. So collaboration is hard. Huh? Oh, okay. Yeah, if you have questions, please ask. And also doing things at scale is also hard. Automation of common tasks or even automation is sometimes hard because of course, we do CI/CD, but typical is a dedicated server for one team, and if that server is busy, you have simply to wait. And for teams not having CI/CD, they have to find somewhere a server, and then someone has to maintain the server. So all those things, they are there a bit, but they are hard. And because we're running all those kind of things ourselves, at least 20 different version control systems on-prem, somewhere on the server, getting new features from the vendors, enabled for our developers, takes years. And no new features make you faster. So we end up in slow, not easy to work together. That's something we would like to change. So for that, we start adopting InnerSource, really to build a way how we can collaborate through the whole company together. And that's not only on source code, that's also to unlock knowledge, skills, documentation, and so on. So InnerSource is the way how you can work in a company together, like you do open source, let's say, everyone on planet Earth. So InnerSource is then the direction forward. Now, that was already invented, I think, even before I started at the company. So we go a bit back to the dark ages in my company on InnerSource. So we see here a nice silos. So we were working in a siloed environment, and we would like to get a little bit away. And we started with InnerSource. So remember, we have all those kind of version control systems. We had a wise team at that time sitting together to say, how are we going to do InnerSource? And they came with a plan, and they say, we go to create another tenant, another TFS tenant, and that is the InnerSource tenant. And there you put your InnerSource code. Nice. And then everyone can use it if your InnerSource code is there, if it is approved, if you have a process in place to get changes in, and so on and so on. So if you're lucky and you was able to find this place in all those places, and you find something that was useful to you, and you start using it and you discover a bug and you want to fix the bug, then you had another problem because there was no way to make a contribution. Fork, not existing. Pull request, no option. So even if you're not tired at that moment, you was able to find out the owner of that component. You say, hey, I have a bug, I fixed it. And then you got a message back, yeah, we know it, we already fixed it half a year ago. And you, what, half a year ago? Yeah, it's not back on InnerSource because the sync is half a year out. Oh my God. So that's where we ended in our, let's say, first years of InnerSource. So, not good. We continue. So that whole experiment was stopped and we rethinked ourselves. So we thought, what should we do to make this successful for our company? So a couple of things that we thought were important is have one single ecosystem. So one place where all our code is. And could it then not be better that all our code is on one single place instead of having all those different services? That would be a nice direction. Of course, we are in all kind of an enterprise, so we have all kind of compliance rules. We are in the medical domain, so we have to take compliance into account. To make this scalable in a company of 8,000 developers, we really have to think about principles from self-service. And so we are still back in 2020, and so we brought self-service is very important. We were a typical company where we have all kind of ticket systems. You file a ticket and you wait for some time and then it gets solved and you could do your work. No, it should be truly self-service. And we should build a community. People that know how to find each other can ask questions. And not only asking questions because you know who knows the problem. You walk around in your company, you find them at the coffee corner, know a true place how you can find each other. So for doing that, we choose to move to GitHub Cloud, which is just a choice in our company. You can use another platform as well, but for us it was important we choose a single platform, which already is known from how to work on open source, how to collaborate, and we try to copy that pattern internally. Another thing that was important for us that we say, InnerSource, sharing your code becomes the default. So in the past, typical code was closed in the silos, which is easier because if your code is closed, no one is looking at it, no one cares about your quality. It's perfectly fine to put secrets in your code, all kind of those patterns. They're not happening on my company, of course, or only on yours. But if you go to InnerSource as a default, then you really have to change the culture. People have to build the trust that they can share the code. So we said InnerSource is our new default. And of course, it's still possible to have complete closed sources, also in GitHub. So we define source code levels. So the default is sharing, but you can go for an exception with a good reason, because there's IP, there's some kind of, let's say, company secrets there, not secrets for deploying, like say, legal secrets. Then you can have a closed repository. Another thing that we thought we can tackle at the same moment is make CI/CD simple and out of the box available. Because what I mentioned, we have teams for who that was still hard. They are bounded to let's say, physical machines. They have to maintain it. They have not enough capacity. They have maybe too much capacity, all those kind of patterns. So can we not make the system as simple as possible for them, but do that with an enterprise need? And if you are in a big enterprise, maybe you know, you have your own version of the internet, your intranet, which blocks everything, which nothing works, but that's your network. We have that as well. It's our Philips network. And all our tooling is running inside that network, or let's say, most of the tooling. So to do a CI/CD job and connect to a quality system, a security scan, you need to be on the network. So utilizing from a cloud vendor, from GitHub in this case, the provided action runners is not an option because they cannot connect to the network in 2020. So GitHub hosted runners was not an option. So okay, self-hosted runners. And then the next question, are self-hosted runners from GitHub you can use for other kind of reasons, but let's say in any way you want to have more control over your own CI/CD, then self-hosted runners is a choice to go. So it could be hardware or software or network or security, or you would completely disconnect it from the world. This could be an option. Now, our mission was, we want to make the GitHub self-hosted runners as simple as open source for InnerSource. So here on this side, you see that is for you the left side. You see how you use typical GitHub runners in a pipeline definition. So even if you don't know GitHub pipelines, this is just a standard YAML from pipeline definition. And on the right side, we see how we do it for self-hosted. So that is what the developer should know. And then it should be magically run somewhere. So we have to build something for that. And again, we can do that manually. What we already did for a long time in my company. So we can buy more machines, install the runner. And at the moment, new software is outdated. We go along and update them all. Of course, this is not what we do. So we forget that. If we were living in 2020 in today, we would ask ChatGPT how to fix it. And even ChatGPT is not coming with, in my opinion, with the right solution. It gives you all kinds of suggestions how you can do something in the Amazon Web Console. Then still you have the transformation to make it to some kind of infrastructure code language. I think you all know Terraform or something like that. So what we did, we built something ourselves because there was nothing available at that time. So otherwise we would find something open source, but there was nothing. Even if you know the Kubernetes runners for GitHub, they were not there at that time. So what we did, we looked on what GitHub has. We said we make our own copy. We built a simple control plane in Amazon, which are a couple of lambda functions. They get an event from GitHub. And at the moment, the control plane decides this is a valid event. It creates a runner, an Amazon EC2 instance over here. And there the job will start. And you can do it in such a way that the runner is completely ephemeral. So every job a new EC2 instance. So you have a complete guarantee on security isolation. But you can also reuse them. So this framework we built. What we next did is open source it, or actually when we were building it, we open sourcing it, which was also at that time a bit scary for us. We open sourced it and we got quite some adoption. So over the years, we got many contributions. Bringing features in like support for Windows, which we also need and not build. The repository was mentioned by ThoughtWorks in the radar last year. So those are all nice things when you do a project like this open source. The other alternative that you have is a Kubernetes approach that is today maintained by GitHub. If you would like to check out more, you can find the QR code on the bottom. So that's what we deployed in our company. We start slowly with a couple of repositories and scaling over time bigger and bigger. And every time you scale, you find other limits because Laptas also has limits. So you can have, and you have CPU limits on your spot instance. So you find out time by time limits. But today we're running on a single day with a maximum of, I think, 40,000 virtual machines that are getting created and destroyed. And we have hardly any problem. The biggest problem we had last year were outages from GitHub. So I think we do a pretty good job here. Now, I can show you a short demo. This demo is showing you how you set up the framework that we have built. The first step that you have to do is defining GitHub and GitHub app, because the app is going to send webhook events to your cloud. So here I show you the repository very quickly. It's already the version of half a year ago. And the next step is that we define the GitHub app. That's what we do here. Once you have defined the app, it's a Terraform module. So you have to define your Terraform module in code. So you have to use our Terraform module, and you define, you inject the network. So you control your own network. You inject the network in the runner. And next you define what type of runners you would like to have. In this case, we set up I think a Ubuntu runner, an Amazon Linux runner, a Windows runner. It are those configurations. The next thing we do is typically run a Terraform apply. And that should go now. Hopefully that goes fast enough. So this is deploying all those resources by this open source module to your cloud, to your Amazon account. And once this is done, we can start a job in GitHub, so a GitHub action job. And of course, this is really a demo setup. So it's for for only one repository with a couple of builds. But in our company, we use this for thousands and thousands of repositories. Here we trigger the build. Yeah, and then we should see on the right side, it's a bit hard to see, but we will see that instances get created, and I think in a couple of seconds, jobs will start. Yeah. Yeah, there was indeed. So why we choose EC2 is because when we built this, actually it was in the week that COVID all started, and we need to get something out very soon. We know the model that GitHub itself has with Azure was working. So the thing that we did, we thought we take the most simple approach, is EC2. The other reason we had to choose EC2 back in the days is we already knew if it was working, we certainly need support for Windows. So that's the reason why we took EC2. At that time, GitHub was not supporting ephemeral runners at all. And so a lot of the things that are here were in the beginning days not supported by GitHub. They even came to us to ask, can you discuss with us about new features? So ephemeral was not there. What we do today to have it very fast is we pre-built our AMIs with everything in, so we can boot them very fast. Otherwise, ephemeral won't work. We have a small pool available, so most users will experience that their runner will start in seconds. And if you talk about monitoring, of course, we have monitor dashboards for this as well. And here we started only with one metric to monitor. Out of the 100,000 things you can monitor, we only monitor how long does it take for the end user that his job is starting, because that is the thing people care about. If that goes up, then we have a problem. Of course, we monitor a couple of more things today, but that's where we started with. There is someone on the open source repository that is looking to support ECS, so hopefully we get it in. It's open source. So I mentioned already self-service. Self-service is key. So we built this whole runner fleet. So that's nice for the operation team, but for the users, they only need to have their job running. They don't care about all those Terraform code. They don't care about anything in Amazon Cloud. They even don't care about that it's a nice and shiny open source project. For our end users, it's all unimportant. The only thing they care about, their job is executed, and they don't have to bother about build machines. To get access to the runners, there needs to be done a couple of tasks. So technically wise, the repository needs to be installed in an app and be part of a runner group in GitHub. So that are administrative tasks the user cannot do himself. So how do you do it? Classically, you make a ticket system available and you ask users to file tickets. You have people watching the ticket system and then do the task. And then we end up with blocking things. And we think it should be truly self-service. Other patterns that we have here is getting new members on our Philips internal InnerSource organization. That can also be solved with tickets, but we think it should be truly self-serviceable. And even if it is about administrator, who is using GitHub? Quite some. Who is the administrator on GitHub? On the org? Only a few. So the very nice feature on GitHub is if you are administrator on the org, you are administrator on every single repository all the time. So you can make all the time only very bad mistakes. That's what you can do. It's horrible. So what we did is we say, no one is admin anymore. You go to make a self-service request to become admin. And then you will only admin for a short time window. And after that, you get automatically demoted, or you demote yourself even better. Now, we implement that through something we call issue ops. And issue ops is where you have GitHub issues. And GitHub issues, you define what you want based on template. You have the automation running in GitHub Actions. So in the pipeline, and then the pipeline is doing the task. And the nice thing of GitHub issues is that every time you change an issue, you get an event, so you can trigger a pipeline based on the issue. Now, simple as that, we can implement that. So for the GitHub runners, we have implemented something what you see here. Someone is defining an issue. Hey, that's me. And I want to have my repository that's called welcome here connected to the runners. It gets automatically processed. I can do my checks in the processing. And if everything is fine and I trust everything, because that's where you have to be very secure, I enable the GitHub runners and I give the user some information back. So that's what we do with issue ops. So it's non-blocking. The user can go to a repository, fill in an issue template, and then everything gets processed automatically. Non-blocking. And it scales. The administrator example that I mentioned, I wrote in a blog together with GitHub. You can find it behind this QR code. It tells you how to set up that for your org. So you can really remove the standard administrator role. Now, compliance, I also mentioned, so compliance is also important. So we do here two major things at that time. So this is still looking 2020, 2022. We have a bot running. A bot is checking our repositories, InnerSource repository, for all kinds of patterns. So a pattern could be, are you using GitHub hosted runners because we don't allow them today? Or a pattern could be, in this case, I want all our repositories should have a file that defines how are they classified related to export control. So this bot is running on all the repositories, and at the moment there's something incorrect. It creates an issue to guide the user how to fix it. So again, we're not blocking from creating repositories, we only tell you how to do the right thing. And for welcoming new users, so we also have enabled users to onboard themselves or their team members, and then every new user gets a new issue where it is giving some guidance on how to onboard and how to learn the things that are necessary. So a course for InnerSource is in this issue related. So we give them instruction, but we don't block the teams again. And for this, technically wise, we built another thing, because we are still tech guys. So we built a data pipe, and the data pipe is getting from GitHub, again, the event. It goes somewhere in Amazon in our case, on the event bridge. On the event bridge, we delegate an event for new members to a Lapta. The Lapta is processing that event and then creating a welcome issue in a welcome repository. So that is our data pipe. We thought maybe we need this later. So the community, also important. So this is also a big struggle over the years. We started with all kinds of initiatives on internal let's say Microsoft type of tooling. We tried the GitHub discussions, all not working very well. And then finally we decide to move to Stack Overflow, where we use it as a single Stack Overflow for the full company, where people can ask questions. And they can ask their questions in company context, because normal Stack Overflow, you have to filter all the company data out and you can post it there. But we have a big company, big community, so we can ask each other here questions. And we even, if someone is emailing me with a question, hey Niek, how can I do this? And I mail them normally back, please, can you post it for me on Stack Overflow? I will answer you there, because then other people also can learn from the answer. And what happens today is that they do that, but before I can answer it, it's mostly already answered by someone else. So this works really for us very well. So that is the 2 years from 2020 to 2022. And I think we built something very nice. So we have using GitHub, we have runners, we have a community of Stack Overflow, but still you really have to know where to go. So for onboarding a member, you go to repository A. For requesting runners, you go to repository B, and so on and so on. So we are getting away from our classic silos, but for the developers, we build new silos because you need exactly to know in which silo you have to do what. Question, you go to Stack Overflow. Documentation, oh yeah, you have GitHub pages, so you have somewhere your own GitHub pages. And searchable, not at all. So that's a bit what we learned from those years, that we're moving the right direction, but we're missing something. We're missing really a place where we can bring everything together. And that is where we thought about bringing the developer experience to the plate. So where we think we should really focus on how the journey is from the development teams. How do we ensure that they have the right environment? Can they really do their job as most effective, and can we truly enable them? So as where we started with InnerSource, we start learning the full community in our company, and we start having taking care about the full developer experience. So today, we're also looking on topics, how can we enable teams to use tools in their IDE, like for SonarQube, for SonarLint, or what do we have to do to enable tools like dev containers, or can we make generative AI available for them? All those kind of topics are becoming to my team today. And to give them a one start point, we start with the developer portal based on Backstage, or also called the internal developer portal. And we start onboarding, we start using Backstage as a platform in our company. And Backstage has a couple of features, and we'll come to them step by step. So the first thing is the software catalog. So if we all think of source code and you say, oh, everything you can find in GitHub, then you have to know where it is and what kind of code you're looking for. You can search it, but you're not searching for your components, the systems you have in your company. You search for the code, which is nice, but it's not typical what people are looking for. Then you already typical know where you search for. So, but our system is also more than only our source code repositories. It could be an email service, is also a software component in your catalog, or maybe a database. So that's what we did here. We start using Backstage for defining a software catalog, and there people can define themselves their services, their components, their systems, whatever they need. The example you see here is in GitHub Action Marketplace. Another thing we have in the catalog, and here I masked most of the stuff because it's internal. But what you see here is people can now search in developer portal, and it search through different systems. So it searched to the Stack Overflow I was mentioning. It searched to the developer portal itself. It searched to our legacy Confluence, where a lot of valuable information is. So teams can search in one single place for all the information related to development. So that's also part of Backstage software catalog. And then automation. And I mentioned we used IssueOps for automation to build automations. But it worked, but it's also not easy to use. And especially for the end user, it's truly difficult because you can make too easy mistakes. It's also hard to extend for other teams. So what we did here is we took also Backstage automation templates to build automations for common tasks in our company. So we built automations how to start an InnerSource repository. We built automations how to get connected and set up your repository for SonarQube. And so more examples, standard workflows, all those templates we have here. And more important, our teams can build their own templates and create a pull request to get their template in Backstage. So Backstage is also deployed in our company completely as InnerSource, because teams can extend the templates with InnerSource model. So here you see an example of a component. So I showed you the GitHub runners we have. So here you see the GitHub runners in the portal, and you see a view how teams are seeing service components. So you see, in this case, the runners in the status. So are they all healthy or not? And if there are incidents are also shown here. On the top, you see also automation again. So the automation that we have with IssueOp for the runners, it's still there, it still works. But what we did is, now we have it available in the developer portal. So teams can go to the tab automation, start the automation to connect their repository to the runners. They fill in, I think, 2 or 3 details. And then under the hood, Backstage is making that old school issue. So we still have the IssueOps legacy, but for the end user, it's just using the portal. Tech docs is another thing. When we were using GitHub in the first years, we saw teams really liked building their documentation pages. But they also don't like it because they don't like to make the documentation pages working. They have to build their own styling and everything like that. And it was not searchable. So what we did with Backstage, we made it for teams very easy to make documentation pages, but they are part of the developer portal. So they become truly searchable and they are automatically deployed. So the only thing they have to do is put the documentation in the repository. Other nice thing when you have your documentation with your code is it ends up in the same review process at the moment you're making code change. And I think you all know if you have code here, documentation there, what is up to date? Code. Who thinks the code is up to date? Who thinks documentation is up to date? One person. I would like to chat with you later. Compliance. This is very broad domain, so I give only here one example. But in the developer portal, we brought views to show compliance for the source code. So there could be a view on the compliance related to software quality. So what you see here is data. It's just coming from other systems. So I think this data is coming from SonarQube. I think this data is coming from code scene. So the data is just fetched from other systems. So we don't build anything here. We typically build on top of open source, and we use data already available in all systems. We bring just the views together. Similar views we have for security, for example. And we have big teams in our company say, yeah, we need more. We need it slightly different. And they build their own views. They don't build a full system. They don't have to manage a full version of Backstage, which is quite hard to manage. They only have to build another view layer. That's all. They make via InnerSource a pull request, and their view layer get enabled for them. Good. Another thing what with Backstage is great is teams can just simply add a catalog file in their repository. And with doing that, they specify exactly how the component should be available in the software catalog. And the catalog file gets detected by Backstage. To do that, if you're a small company, it's easy because you can just scan all your GitHub repositories in your org. If you're big, with over 10,000 repositories, this will crash. And you cannot scan all your repositories continuously. That is not going to work. So that's also where we use the event pipeline. I was showing you a little bit earlier with the welcome issue. We use events from GitHub again. Every time the catalog file for Backstage is changed, there's an event fired from GitHub, and we update only that component. In that way, we are truly event-based, and we are not brute force try to find all the changes in our orgs. As mentioned, so we have quite good adoption on Backstage in our company. Teams really start using the tool. To do that was quite hard step because it's new. how do you get people convinced? Because moving people to GitHub was actually not that hard. With a competing feature like CI/CD is getting very, very easy. But being on the developer portal, they don't see that much need. So for that, we ran hackathons on our major hubs to get really people and teams used to Backstage and find out what's the value for them. But it is fully InnerSource, and the adoption grows. We also make development easy for them with dev container and code spaces. So starting on on the developer portal with developing is not hard because your environment is completely defined, and with a click on the button you can start. Technical wise, again, no Kubernetes, so I think you get really bored here. We are a very small team. My team is 3-4 technical people. It's hard enough to maintain all those kind of stuff. So what we typically do is we choose the most simple way we can do things. Here we run the developer portal just with Fargate and some other services under the hood in Amazon. So S3 for the tech docs, RDS is just a database. And to make the search working, we use open source, all managed service from Amazon. So we don't have to manage anything. It's maybe cheaper, but we don't have the capacity. So then we have nothing. So that's our choice. We want to speed. The speed is the most important thing for us. We are not the we are the one big silo. Yeah. So yeah, we started on GitHub. That was already a great experience with the developer portal. I think we make another big step where we are today. So we had our own legacy from 2 years on focusing only on GitHub, but in the end it was not hard to move that to the developer portal. Our issue ops could easily transform to templates, and over time we can move away maybe from issue ops. Compliance we can make visible very easily to bring right in the face of people, you are not compliant. Our way about asking things on Stack Overflow is still there, but we combine it with the developer portal. So if you go to a specific component in the developer portal, you see also the relevant last 5 questions on Stack Overflow for that component. Status of services we can make visible in the developer portal, so no external status pages anymore. And yeah, the eventing is really important for us to scale the system. So where are we today? So when I started on this in 3.5 years ago, 4 years ago, we were with 10 developers on GitHub. Today we are with 5,500 developers there. So we have about 2,500 to go. We're quite happy with this. We have a lot of repositories there. I think number of repositories does not say that much, but it's big. And the jobs, yeah, it's also growing. If you look to the graphs, they all go in this way, all graphs. So continues going up. Yeah, if you would like to find all the stuffs I use in the talk, you find them here. You have to read through Terraform code to understand what's there. But mainly it says, here you find the slides, and if anyone, I'm available on LinkedIn for more questions. I will be, after my talk, here somewhere around in the hallway. Feel free to ask any question on how we do it. Yeah, and I think we have a bit of time for some questions.